Kincardine-on-Forth swing bridge was built by the Cleveland Bridge and Engineering Company of Darlington in 1936. It was the first road bridge to be built across the River Forth east of Stirling and provided a vital direct link between the counties of Fife on the north side and Stirling on the south side. The bridge had become necessary because of the rapid increase in the number of road vehicles during the 1920s and because of the inadequacy of the local ferry services. It cost £322,500 to build, an impressive £60,000 under budget. The site at Kincardine was chosen because the Firth of Forth widens to 3 miles immediately to the east towards Grangemouth. The rival site at Alloa was rejected on the grounds of poorer access for traffic and greater construction costs. The width of the Firth of Forth at Kincardine narrows to only a maximum of 2,400 feet at high water and proved to be the most obvious crossing point. The bridge replaced a small passenger ferry, the piers for which can still be seen 150 yards to the west on the upstream side. Before 1936, the nearest crossing point for vehicles was a primitive steam ferry boat 4 miles upstream at Alloa, and the closest solid bridging point was a further 9 miles to the west at Stirling Bridge. The Kincardine Bridge therefore saved an average detour of 50 miles for road vehicles. Despite the obvious advantages of the new bridge and the need for economic revival in the interwar Depression years, the project was delayed from 1931 to 1933 by a sudden reduction in central government funding from 85 to 75% of total costs. This obliged the Fife, Stirling and Clackmannan county councils to find an extra £30,000. Construction work began in December 1933 and took almost 3 years, employing an average of 150 men on site throughout that period. The bridge was opened to road traffic on October the 29th, 1936. In addition to work on the bridge itself, a great deal of disruption occurred in the town of Kincardine, where substantial demolition was necessary to make way for the carriageway leading up to the bridge. This can be clearly seen in these contemporary photographs. A curved viaduct section was built to minimize the damage, but many people had to be rehoused. The bridge had been designed by Sir Alexander Gibb and Partners and conceived as a multiple span structure with 6 distinct sections. Of these, only the central steel span is the swing section, all the remaining parts being fixed. The 6 sections of the bridge combined to form a total span of 2,696 feet. In the distance on the south side, there is a 265-foot-long pile-reinforced concrete viaduct. This is followed by a section of 9 reinforced concrete spans, each of 50 feet, with arched underside beams. Leading up to the central swing section, there is a sequence of 7 steel spans, each of 100 feet. On either side of the central swing span are 2 large concrete portals containing safety gates which descend when the bridge is about to swing. The portals, like the piers of the bridge, are concrete, made from English Portland cement. Immediately on the north side of the swing span, there is an identical sequence of 7 steel spans supported on reinforced concrete piers. The final portion is a curved viaduct section of 3 continuous 62-foot 6-inch spans which lead onto the north bank and over the railway into the town of Kincardine. Since the opening of the bridge, the volume of road traffic has grown steadily. In 1936, Over 1,200 vehicles crossed the bridge between 6 a.m. and 10 p.m. every day. By 1987, it was estimated that the bridge carried an average of 21,500 vehicles per day. Power for swinging the bridge is provided by an engine room in the base of the centre pier, which is itself supplied with electricity from the Fife shore by underwater cable. The swing section weighs 1,600 tons and rotates on a radial assembly of 60 solid cast steel rollers. The entire bridge opening procedure is controlled from a beautifully maintained control room, which has retained all the original fittings and open switchboards. The control room is suspended in the superstructure of the swing section above the road level. To the onlooker, the opening procedure begins with the sounding of a warning siren, the changing from green to red of the traffic lights, and the descent of the safety gates. All road traffic is forced to stop once the gates begin their descent, and travellers must wait for at least 13 minutes. Whilst waiting, they can observe the 3 county plaques displayed on the portals and the interesting finish effect on the concrete. This was achieved by using Hessian-covered shuttering. In the control room, the opening procedure continues, controlled automatically by the original GEC electrical switchgear. Down below, in the engine room, a Tangy 25 horsepower hydraulic pump is activated, retracting the wedges and locking bolts. The central swing span is now free to rest on the rollers, and the bridge is ready to swing. 2 50 horsepower, 440 volt electric motors induce rotation through large trains of gears on either side of the engine room. The initial opening process takes about 2 minutes. The gearing produces a 171-to-1 reduction, and the bridge revolves slowly on a circular cast steel rack with 224 machined teeth. The opening of the bridge allows for a better view of the deck structure from a central wooden jetty near to the water level beneath the engine room. Although the steel construction appears to be comparatively simple, much thought and design was necessary in order to ensure the longevity of the bridge. For example, the deck had to be fully sealed and waterproofed to prevent corrosion caused by water and salts penetrating the bitumen surface above. Also, such large quantities of steel create complex rates of expansion and contraction in different temperatures due to weather conditions, all of which had to be considered in the final design. Once the bridge has been opened, it must be locked in a central position. At this point, semaphore signals on each of the ends of the central wooden jetty indicate to waiting vessels that it is safe to pass through. Meanwhile, the gearing is checked to make sure that no problems have developed in the first stages of the opening procedure. This became especially important in recent times when bridge openings became so infrequent. In 1936, it was envisaged that the bridge would open 30 to 40 times a month, with probable increased numbers of openings in more prosperous times. In fact, river traffic tailed off as silting problems increased and the closure of Alloa docks reduced still further the need for so many openings. Today, only small ships and boats travel upstream to Alloa and beyond, none of which require the extra clearance provided by the opening of the bridge. Closing the bridge involves the same procedures as those for opening, only in reverse. This also takes approximately 2 minutes, the swing taking the bridge back into a closed position. During the rotation, the entire 1,600-ton weight of the swing span rests upon 60 cast steel rollers in the central pier beneath the engine room. The rollers are 16 inches long, are tapered, and have an average diameter of 20 inches. Were the bridge to sit with its full weight on the rollers for any length of time, the rollers would become distorted, preventing a smooth passage during the swinging process. It is for this reason that wedges are used to lift the weight of the bridge off the rollers after each opening is completed. However, the swing span must be very carefully realigned before the wedges and bolts are reinserted, raising the deck level back to that of the rest of the bridge. Once the bridge is secure, the safety gates at each end of the swing span are raised into the concrete portals. After the 13-minute wait, the traffic is now able to continue its journey either north into Fife and Clackmannanshire or south into Stirlingshire. Road traffic is now more dense than ever, but in contrast, large-scale river traffic shows no prospect of any form of revival. For this reason, following a final opening on the 31st of January 1988, the bridge was permanently closed, rendering it a fixed structure. The control and engine rooms are, however, to be preserved in the care of the Bowness Heritage Trust. A brief car journey across the bridge confirms that it was built both with function and elegance in mind. The portals, railings and lampposts all combine to pleasing effect. It is interesting to reflect that the bridge was built in the open position, and that at the opening in 1936, it was actually closed into its current position to allow the first road vehicles to cross. Despite the success of the new Forth Road Bridge, completed in 1964, 14 miles to the east at Queensferry, there is no doubt that the Kincardine-on-Forth Swing Bridge will remain of vital importance. This was the first Forth Road Bridge and has many decades of active service ahead of it, even in its fixed form.